Hi everyone, this lecture is going to have two learning goals. The first is to understand the key features and biases of probability sampling. And the second is to understand the key features and biases of non-probability sampling. All right, when we think about sampling, it's a term that we're often hearing and discussing and critiquing in research. The idea is that we're thinking about who it is that we're trying to describe or explain. When we conduct a study, when we draw a sample into our research study, the main way and criteria that we're thinking about when we draw that sample is who is it that we really want to find out about, who we want to learn about, who we want to create generalizable statements about. And when we think about social science research as a just broad endeavor, you might say, well, hey, who we want to describe or explain is all human beings. We would really like to make generalizable claims about how all human beings operate and think and so forth. That's a really huge endeavor and one that not a lot of researchers, very few, honestly, researchers are trying to do and would argue that is really possible to do. We'll see why as we kind of talk through the logistics of sampling. So we're often, when we're doing research, thinking about smaller kind of populations of interest, smaller groups of people that we might be interested in. And the important thing being that depending on the research questions we have, the size of the group that we're actually interested in might vary quite considerably. So if you imagine all human beings, that's a huge, huge, huge number. We could narrow that down by saying like, oh, well, maybe I'm just interested in generalizing about all people in the United States of America. Getting even smaller, I might be wanting to just generalize about all voters in Ohio. Even smaller, I might just want to make generalizable claims about all freshman Ohio State students at this university. Even smaller, I might just want to make generalizable claims about Ohio State communication students at this university. Or even smaller, even more narrow, I might just want to understand and make generalizable claims about the students within this particular class, this Communication 3160 class. So when we think about samples, we're thinking about what are the groups that we're actually interested in trying to make generalizable claims about. So let's put a couple of definitions up so we can think about what this looks like. So we're two terms that I was just kind of throwing around that I want to clarify is that we have populations and we have samples. When we think about populations, this is the group of individuals about whom we wish to draw conclusions in a study. And the sample is the group of individuals who are actually included in the study. So who is it that we want to make generalizable claims about? Is it all humans? Is it everybody in the US? Is it people in Ohio? Is it people at OSU? Is it comm students at OSU? Is it people in this class? The sample is who I've actually invited to be in my study. So within that big, huge population, who are the people that I've actually invited to be in the study and provide me information in my study? And there are two key major ideas that we're thinking about when we think about samples and essentially why we care about samples and how they were drawn and how we end up with the people we end up with in a study. The first is the idea of representativeness. And the idea here, it's the characteristics of the individuals in the sample are consistent with those of the larger population. When we're conducting a study, if we don't want to kind of measure everybody that exists out in the population, if we just want to measure a subsample of it in a way to make the study more possible to conduct, I would want to hopefully have a sample of people who generally represent that larger population they were drawn from. On average, they kind of have similar characteristics overall as the broader population from which they are drawn. So ideally, in a perfect world, when I'm conducting a study, I want to have representative samples. They represent the population which they were drawn from. And ideally, I want to have what we call generalizable findings. It's the ability of the observations made from my sample are going to closely match the observations that would appear if I had actually been able to study that whole population. So if I'm looking at something like social media use and attention, the kind of estimates I have of those variables in my sample and the relationship between those variables in my sample would actually generalize to that larger population. It actually closely matches what I would have seen between those variables if I had measured everybody in that population. The limitation here being that I generally cannot measure my entire population. It's just financially unfeasible. I don't have the time, whatever it might be. So I want to try and draw samples where the sample that I draw is representative of the population and is allowing to me make generalizable claims about the population. And the basic idea here is that representative samples tend to produce generalizable findings. So if I collect a nice representative sample from my population, I can be pretty confident that the patterns and relationships I see in that sample will actually generalize to the larger population. So that's why it's really, really critical when we think about sampling that as much as possible in a perfect world, we could collect these representative samples. But the big picture here is that there's really two types of sampling. There's probability samples and there are non-probability samples. Probability samples are going to use some elements of random selection such that every member of a population has an equal chance of being chosen for a study. And a non-probability sample uses non-random selection, such that participants are selected for a study just out of convenience or availability. Now, I want to make two big points here, then we'll get in the nitty-gritty, and then we'll come back to these 2 points at the end, is that probability samples are much more likely to generate representative samples and to have generalizable findings. Non-probability samples are very unlikely to create representative samples and are unlikely to have generalizable findings. And despite everything I'm going to say about how great probability samples are in just a moment, so little research actually relies on probability samples that we do. We often are relying on non-probability samples. So I want to mention that point now because I'll re-emphasize it and talk more about it at the end. But I want to emphasize that the probability samples that I'm going to talk about are a dream for many, many researchers and is something that doesn't actually often happen in practice. And we'll talk about logistically here as we go through why it's so difficult to actually draw these probability samples. So when we think about a probability sample, in order to have a probability sample, I need to be able to create what I call a sampling frame. This is going to be a list of all individuals in a population. So literally just a big list of everybody in that population that I want to generalize about. And my sampling frame is going to allow me to randomly select individuals from that list to be part of my study. I'm going to go through that list and I'm going to have a random number generator just tell me who is in and who is out of my study, and that's how I'm going to collect my sample. And if we do this, it's going to have the best chance of approximating the population that we can really imagine in any kind of research design. So if we are able to generate the sampling frame, if we're able to randomly select individuals from that list, it's going to give us the best chance at approximating the population, at having a representative sample, at having generalizable findings. If we cannot generate a sampling frame or a list of everyone in our population, we cannot take a random sample. Now, there are ways around that. We can sort of start with bigger picture groups, like maybe 50 states, and say, I'm going to randomly select 5 states from this 50, and then randomly select 5 cities from each of those states, and then randomly select 5 neighborhoods within each of those cities. And then if I can get a list of everybody in all of those cities, then yes, I can still be taking a random sample, and that's still going to work the same way. But so I can kind of if I can funnel down into a meaningful sampling frame, I can still do this. But if I'm unable in any way to generate a list of every single person, or in these cases of really, really big populations of funneling down to a meaningful list of people, I'm not going to be able to do a probability sample. So I say that because you can imagine there's going to be a lot of situations where it might be really, really difficult to generate a sampling frame that would enable us to actually draw a probability sample. Let's think about some examples of lists that maybe do exist, but then we'll talk about some limitations and problems with those lists. So if we think about everyone living in the USA, well, hey, every 10 years we conduct a census. We try to actually do a survey of every single person who lives in the United States. And so we might say, okay, I'll take that list from prior census data, and there's my list of everybody in the US. Great. That's my sampling frame. If I was interested in making claims about all the voters in Ohio, I could look at an existing voter database and say, okay, I'm going to see who is currently registered to vote in Ohio, and I'm going to get a list of all of those individuals. I'm going to randomly select from that list. For OSU students, I might generate a list of current enrollment data and randomly select students from that enrollment data list. If I wanted just communication students, I might limit that enrollment data to just those who are currently enrolled and declared majors in communication, randomly select from that list. And if I wanted to make claims about the students in this class, I might just use my class roster and randomly select students from that class roster. So we have lots of different sizes of populations here, and we can think of different ways that we could theoretically generate a list of everybody in that population. Now, who can access some of these lists? That's a different question. But we could feasibly think of ways that those lists could be generated. And because of that, we could generate a sampling frame. We could randomly select from that frame, and we could get a probability sample. When we get really big, when we think of something like all human beings, I don't know how you'd get a list of all human beings and randomly sample from that list. So that's where when we start thinking about, oh, I want to make generalizable claims about all humans, from a numbers perspective or logistics perspective, we're just probably not going to be able to do that. There's no sample I can really draw that's going to meet these criteria for a ideal probability sample. Given those issues that I've just laid out, you can start to imagine, well, okay, there's going to be some issues each time we try to make a list of individuals in a population to actually draw this sampling frame. And we call those those are going to as coverage biases. So these are going to be issues with the sampling frame that lead to differences between the makeup of the sample and the makeup of the population. And that's because any list that we generate about a population, it's not going to be perfect. Like, even though theoretically, yes, the prior census data has everybody on it in the US, there's going to be some issues with it. Even though I can generate a list of current enrollment and communication declared majors, there's going to be some issues with that list that we generate. And there's two general types of coverage biases that can occur. One is an undercoverage bias, which is when individuals in the population are actually not included in that sampling frame. And overcoverage biases, where individuals in the sampling frame are actually not part of the population. So in one case, we're missing some of the people that we really would like to be potentially including in the study. And in another case, we're including people in the study potentially that we don't actually want to know anything about. And a visual representation will be helpful here. So a visual representation, let's think about if I have this population of interest, this group of people I would like to draw a sample from to make generalizable claims about. I might create a sampling frame that includes some of those people, but then also includes some people that I'm not interested in. So the group that is in the population but not covered by my sampling frame, and then the group of people who is in my sampling frame that's not necessarily part of that population. The first case is called undercoverage. The second case is called overcoverage. So this is just a visual to try and help you think about the sampling frame as kind of this group of people that I'm drawing from to conduct my study. And depending on how well aligned it is with my population, it's sometimes going to include people that I don't want, and it's sometimes going to miss out on people that I do want. So let's look at some more practical examples of how this might happen. Consider that I want to predict what's going to happen in the next presidential election. I want to know how people are going to vote in the next presidential election. So I want to conduct a study where I ask people, who are you planning to vote for in the next election? So to do this, I might try to obtain a list of everyone who voted in the last election. Because you can imagine, okay, a good population to draw from is the population of people who most recently voted in the election. And that might be, the best I can do in order to generate an actual list of individuals from which I could draw a random sample. But we know there's going to be some issues with that list. When we think of undercoverage, it's not going to include people who are going to vote in the next election who did not vote in the previous election. That could be both just first-time voters that have never voted before who decide to before the next election, and also those who were maybe too young during the past election who are now of age in the next election. So although I can generate a list of people who voted in the next election and say, hey, that's maybe a good idea of the population of interest, while the population is kind of shifting over time and my sampling frame isn't going to really capture those new people who are now part of that population. And it's also going to include some people who I actually don't want to know about, who actually aren't going to vote in that next election. So it may be people who decide, hey, I'm not going to vote again. I didn't like how things went last time, and so I'm not going to go out to vote. Or maybe I'm working the day of the election. I can't get out to vote. Maybe more morbidly, people who pass away before the next election who did vote in the previous election. And so if I take that sampling frame and base it on the past election, again, the population is going to change. It's going to both include new people who didn't vote last time, and it's going to still include people who aren't going to vote next time. So it's going to be biased in kind of two different ways. And again, these won't be huge biases. It's not going to be a huge number of new voters and a huge number of fewer voters. But it will be biased in a way that you can imagine are going to meaningfully impact the kinds of estimates that I care about, such as who are you going to vote for in the next election. And so it's going to interfere with, for example, if I'm trying to predict who's going to win and I say candidate A over candidate B, the nature of my sample is going to kind of decide, how close am I going to be? How close was my sample to the actual group of people who turned out to vote in the next election? What was the population that actually looked like? And how closely was I able to approximate that with the actual sample that I picked? There's another type of bias that we need to consider, that even when we're conducting high quality probability samples, we might also be concerned about what's called non-response bias. And so that happens when individuals who are selected for participation in a study actually opt out of participating. They say, no thanks, I don't want to do that. Or maybe they don't even answer the call to participate. They just, they miss the call, they miss the email, they don't answer the door when you knock, whatever it might be. So we can imagine in this example of election estimates, if I draw a sample of participants and Republican voters, historically, those who have historically voted Republican or who are registered as Republican, if they consistently choose not to answer my phone call, they consistently choose not to answer my email, or they consistently choose not to answer the door when I knock, I'm going to be missing all those voters in my sample, and I'm going to have a biased sample. I'm going to not have as many Republican voters in there as I would hope in order to be making generalizable claims, in order to have a representative sample. Similarly, maybe young voters aren't responding. You might not be answering anonymous calls on your phone. You might not be, your emails might be getting routed to spam. Maybe nobody's coming to knock on your door because you live in a big apartment building, whatever it might be. I might not have as many younger voters in my sample as I would like. And thus my sample is not going to quite match the population that actually ends up voting. And so I'm going to be potentially misestimating who I think is going to win that election based on who is choosing to participate and choosing not to participate in my study. The key idea here being that non-response bias, people are opting out of participating in my study, even if I have drawn this from this probability sampling frame. We can still end up with a non-representative sample if people are systematically opting out in some way, in a way that's meaningful to the estimates I actually want to make about my study. Pivoting now to non-probability sampling, we'll just talk about three general types that people tend to use and the potential issues that come along with those. So first is what we call a convenience sample. This is a sample of people that are just sampled into a study based on availability. Very common, typical, classic example is, hey, college students, we're going to offer you extra credit for being in this study, so please come participate. Anybody that wants to can rock up to my lab and participate in my study. You're going to get some extra credit. That's convenience. I'm just recruiting you because you're desiring and willing and volunteering to be in my study. A second example is what we call a snowball sample. And this is a sample where potential participants are identified by other participants who are already in my study. So for example, if I had some parents participate in my study, maybe some parents that I know, I say, hey, could you recommend some other parents who would be willing to participate in this study? Give them my email, give them my phone number, and then I just keep having people recommend others to be in my study. This is really useful in cases where we might be working with hard to reach populations. So you could imagine something like if I wanted to study unhoused individuals, I might need to find those who are willing to talk to me, maybe through a local shelter or something like that. And then I would maybe need to ask them like, hey, who else would be willing to talk to me? Just given the kind of difficulty of finding people in that population and maybe the reticence or hesitation they have about talking to researchers, I kind of have to rely on this word of mouth snowball in order to talk to enough people to make any kind of claim or any attempt at generalization. And then a quota is a kind of a almost attempt at a probability sample, but it doesn't actually include those elements of random selection. In this case, you're going to be sampling people based on specific traits. And it occurs in cases where you actually know the characteristics of the larger population you're trying to generalize to. And so you try to collect a sample that has those characteristics. So for example, if I want to know, if I want to make generalizable claim, if I want to try to generalize about the population of the United States, and I'm collecting a convenience sample of people, adults online, I might still try to kind of match the gender balance of people in the US, the gender balance of different race and ethnic groups in the US, and say, hey, I know this percent of the US population is white, and this percentage is black, and this percentage is Asian, this percentage is Hispanic. I might try to ensure that the people I recruit to be in my study, the numbers overall match those kinds of proportions, match those kinds of percentages. And I can do that by setting quotas and basically saying, hey, once I get this number of people that fall in X category, we're not going to recruit any more in that category. Once I get X number of people in this category, I'm not going to recruit any more for that category. So I'm setting quotas essentially. And the nice thing there is that your sample in the end is going to look representative. It's going to have these features that kind of match up to the population it's drawn from, but it's not nearly as good as actually drawing that kind of random selection, random sample, because there's still this element of convenience of who decided to opt in and who decided to opt out that's going to limit what we learn. Again, the important thing here is that all of these cases of non-probability sampling, we're not creating a sampling frame. We're just asking, whoever will actually come talk to me and be in my study to be there. And because of that, we're not actually meaningfully drawing from this bigger population that we would like to draw from. And that's going to mess up representativeness. It's going to mess up generalizability. Returning to the point I was making at the beginning, though, is that a recent review of research in the social sciences broadly, so fields like communication and psychology, found that 82.6% of studies in communication specifically relied on non-probability samples, over half of those being college students participating for extra credit in a study. This is another way of saying that most of the research conducted at universities is non-representative and thus may have limited generalizability. And that's too bad, honestly. But you can see what I've laid out here is that in order to conduct these high quality probability samples, we first need to be able to create a sampling frame. If we can create a sampling frame, we need to be able to access the data in order to create that sampling frame, which maybe has layers of protection or layers of difficulty of actually accessing. And then when we actually draw that sample, we need to hope that coverage biases aren't kind of limiting what we learn, non-response biases aren't limiting to what we learn. And so all these kind of steps and logistical barriers that are in place that make, in many cases, probability samples difficult to collect without a lot of money and a lot of resources. So that's why, unless you have big grant funding and a lot of time to invest, you won't always see studies being conducted with probability samples. But you really need somebody backing you, funding you in order to make it happen. But when we think about representativeness and when we think about generalizability and why maybe the prevalence of non-probability samples is not as concerning as it might seem on its face, is that we care a lot about representativeness and generalizability when the stakes of what we're studying are really high. So things like trying to predict an election, people are going to great lengths to try and collect probability samples. And in cases where they're collecting unrepresentative samples of trying to do these fancy statistical procedures to ensure that the sample is weighted in a way that matches the population. So when the stakes are high, we go to a lot greater efforts to get those samples and then to adjust those samples in ways that make them hopefully more representative. Other high stakes situations like evaluating the quality of a new medicine or a new medical procedure, we want to be pretty certain that these types of things are going to operate effectively and not cause harm and not kill people, essentially. And so we're going to worry a lot more about representativeness and generalizability in those contexts where the stakes are really high. But as I've noted, it can be very difficult and sometimes very expensive, and in some cases just entirely impossible to achieve a probability sample. And so we don't just throw our hands up and say, well, we can't study that thing then. We say, hey, we recognize the limitations of a non-probability sample, but we also recognize the benefits of learning something about humanity than absolutely nothing. We recognize the benefits of systematically investigating an issue rather than just kind of going by anecdotal evidence or observations of yourself. And then in some cases, researchers may be interested in studying groups that are just inherently a small subset of the larger population, where generating sampling frames is really difficult. So we can think about groups like LGBTQ+ individuals and so forth. And so in those cases, we're just really going to take for granted that we're going to need to take convenience samples. We're going to have non-probability samples. But the benefit of learning about these groups of people and being able to provide information about these groups outweighs the fact that it's not necessarily going to be a probability or representative sample. And I've also hinted at different strategies here that we try to use even when we're maybe failing to get a representative sample. We can try like non-probability quota samples. We can try fancy statistical procedures that are, beyond the scope of this class, but trying to adjust our sample statistically in ways that make it more aligned with the population. And so again, learning goals today: understanding the key features and biases of probability sampling, understanding the key features and biases of non-probability sampling. Again, probability samples, really ideal, really great, most likely to create generalizable evidence, but in fact, really, really, really rare in the realities of doing research in day-to-day life.